These are the frequently asked question videos for Algebra 2 for section 7.2, day 2. I wanted to look at number 17 here. Number 17 has y equals a times b to the x minus h plus k, but there's no h. And so this one is just going to give us a shift that's going to be 8 units down when we're done. So our parent function, y equals a times b to the x, is right there. And then we're going to go ahead and translate that 8 units down when we get done. So think about the 1/3, and that indicates that we're going to get some decay. But then we have that 5, which is going to, well, make things move a little quicker than we would normally have them be. So we'll go ahead and put some numbers in here and see what happens. So with a -2, we'll have the reciprocal, which would be 3 squared, which is 9, so that would give us 45. And then a -1 would flip it, reciprocal there, and then 3 times 5 is 15. And then anything to the zero power is going to give us 1, but again, we know it's going to be 0a, so 0, 5. And then you put a 1 in there and you get 5/3. And you put a 2 in, and when you square 1/3, you get 1/9, so this will be 5/9. And we can see that, you know, things are getting smaller and smaller there. So this one is the one that we're going to put on dashed or dotted. And I'm thinking about moving this down 8. I'm going to go ahead and just go by 2s on my y scale to make this a little bit better fit. So normal 1 units on my x scale, but then we'll go by 2s. Boy, the smartboard is just not doing well with that. Alright, so hopefully you can see that. We've got -245, which I'm not going to graph on this scale, but we'll try and get the 15 on there. So -1, 2, 4, 6, 8, 10, 12, 14, about there. Again, my graph's a little bit off because it's high. There we go. And then we have 1, and then 1 2/3, and 2 5/9. So again, it's decay, but with that multiplying by 5, it's a little steeper than what we would normally think is going to happen. But our k value, pardon me, tells us that we're going to need to move this down 8 units. So we take the points that we just graphed and we just move them down 8. So I went by 2s again. So let's see here, 2, 4, 6, 8. Out there. Now, as I get to this point, I realize it'd be really nice to have my new cutoff, my new range, and that's going to be y equals -8, since I'm moving this 8 units down. And there it is. Now with these again, it just said graph each function as a transformation of its parent function. So they're not having us do domain and range, but I'm going to talk about it anyway. Our domain is all real numbers. All x values are okay here. But our range, we notice the k value, and along with a is determining that. What I mean by that is the k value was -8, so y equals -8 is our asymptote. And then our a value was positive, so it's going to be above that. So it'll be y is greater than -8. And again, they didn't ask you to do that, but it's probably going to be something that's on the test where you have to think through that domain and range piece. The next one involved, we're going to talk about continuously compounded. And remember, continuously compounded uses Euler's number. And that is the stinky green shampoo formula, PERT. So there it is. And this one says our principal is 2,000. And then we have e to the interest rate 5.1, so that's going to be 0.051 and the time of 3 years. So we're going to need 2,000 times e to the 0.051 times 3 power. So I already have my calculator up here. I'm going to go ahead and punch that in for you. So we've got 2,000, and then we need that times, and we've got our e to the x button down here, and then that was 0.051 times 3. So I want to use parentheses for that, so that the calculator knows, hey, that is all part of the power there. And there it is. So they should have, we want this in dollars and cents, $2,330.65. 233065. For number 28. So use your calculator appropriately for E. We're not doing a lot with E. We're letting the calculator tell us what that is as we go through these. We use E for this continuously compounded piece that we have for interest. 31 says a student wants to save $8,000 for college in 5 years. How much should be put into an account that pays 5.2% annual interest, compounded continuously? So there's our APERT. And they're telling us they want $8,000. And it says how much should they put in. So we're looking for P. And we have E, that's a number. And we know that we have 0.052 as our percentage, and they want that after 5 years. Get that out of the way. So that's all a part of our power right here. And we realize if we're going to get P all by itself, we're going to have to divide by E to the 0.052 times 5 power. And we might as well throw that little piece into the calculator. 0.052 times 5 is 0.26. So 8,000 equals P times E to the 0.26 power. So if we just divide both sides by E to the 0.26 power, we should be able to figure out what that principal is. So I'm just punching in 8,000 divided by, and then I'm going to use parentheses just to make sure that the calculator knows, e to the 0.26 power, double parentheses, and it is $6,168. And then I see that it's 0.412. But if we want to have that full $8,000, we are going to round up in order to get the full. All right, so next one I'm going to go after here is going to be number 32, which is how long would it take to double your principal in an account that pays 6.5% annual interest compounded continuously. So we're going to use the APERT formula again, but I don't know what the principal is. And when that happens, you can just make up a principal. I'm going to have my principal be $1, and I have E, and 0.065, and it says how many years, so we don't know. We're going to make that a T. And I want to know when is it doubled. Well, that would be $2. So I want to know when is 2 going to equal E to the 0.065 T. And I'm going to use my calculator to do this by using that intersect feature. So let me get in here, clear out what I had in there. And the stat plots are turned off, which is good. All right, so I want a 2 in as y sub 1, and then I want my E, and I certainly don't need the 1, to the 0.065x power. So then my window, well, I might try zoom 6 just to see if I can see anything that I need there. And there is my line for my compounded continuously interest, and I see it's a little bit further out there to the right, and that would be increasing my x value. Now, I certainly could change this to 0 because this is time and time is not negative, and maybe I'll make that a 15. And again, we're talking about wanting to double this, so my number should be between 0 and 2, so I'll just make that a 3. So just tightening up that window a little bit to get a better look at that intersection. So that was my $2 line, and there comes my e to the 0.065t. And then second, trace number 5, and enter 3 times, because those are the only graphs that we have on there. And it says we've got 10.663803. Again, if this is truly in banking, you're not going to get that money until after 11 years. So I would put approximately 11 years here. Because the banks tend to have that rule that you must wait until the end of the year to get your money in order to get everything. The book did go in 10.7 years because in a math world, in a perfect world, you could pull it out then. But like I said, banks will usually make you wait until the end of the year in order to get whatever it is that you're owed. All right. My calculator all set, just in case I have another one here that I'm going to need that for. And let's continue on. Number 35 says, using a graphing calculator, graph each of the functions below on the same coordinate grid. What do you notice? And explain why the definition of exponential functions has the constraint that b cannot be 1. So as I look at these, I notice, well, b is not 1. You know, first it's 1/2, then it's 8/10, then it's 9/10, then it's 99/100. But what they're trying to show me here is that we're getting closer and closer to it being 1. So y equals, going to have that 1/2 to the x power. Oops, it didn't grab my parentheses there. All right, let's try this again. There we go. All right, this thing is really clunky. So now that one's in there, and then the next one was 8/10 to the x power. And the next one is 9/10 to the x power. Didn't grab my parentheses again, little stinker. And then 99/100 to the x power. And I'll do zoom 6. -10 to 10 window. So there's that 1/2 to the x. And there's the 8/10, and we notice that it's starting to flatten out with the 8/10. And the 9/10, even more pronounced there from the blue to the black, that it's getting flatter and flatter. And there is the 99/100. And what we can see is this is getting closer and closer to a horizontal line. And there's nothing exponential about a horizontal line. So it says, what do we notice? It is getting closer and closer to y equals, well, it's eventually going to become y equals 1, so we might as well write down that it's going to be closer and closer to y equals 1. And then explain why the definition of exponential functions has the constraint that b is not equal to 1. And that's because horizontal lines are not exponential. They're linear. So there's nothing exponential about that. If we use a 1, they will be linear. All right, the next one. Number 36 is talking about half-life, and this is something that We didn't really have any examples that deal with half-life, but it's so important that I wanted to make sure I covered it. It says the half-life of a radioactive substance is the time it takes for half of the material to decay. Phosphorus 32 is used to study a plant's use of fertilizer. It has a half-life of 14.3 days. Write the exponential decay function for a 50 milligram sample and find the amount of phosphorus 32 remaining after 84 days. So here's what we do know. We know this is starting off at 50 milligrams. And we know that, like it says, it's a half-life. Each time period, half of it is going to be gone. That's why it's called a half-life. But here's the problem. It doesn't last forever. You know, we can't use X as if it were years. What we have to do is realize this is only going to last 14.3 days. Now, when our life expectancy is in years, we can just plop an X up there. But now we realize that each day is 1/14.3 of its life. So we can't just put X for life, we have to put 1/14.3 for the life expectancy here. And then it says to find the amount of phosphorus 32 remaining after 84 days. So now that you have it set up, you can just put an 84 in here and things will work out pretty good. But it's this part right here that is so important because this is done after 14.3 days. It is not potent anymore. So then we grab a calculator and do our best to get this bad boy punched in here. So 50 times parentheses 1/2 parentheses to the parentheses 1 divided by 14.3 times X. And for number 36, that is 0.85 milligrams. And probably better yet to put double parentheses in here so that you can get all of that to work out correctly when you're punching that in. And you certainly could take 1/14.3 times 84 and then write down your result. Or just use that and keep going with it and kind of follow the order of operations from there. All right, number 37, archaeology. So this is another example where we're using a half-life. Carbon-14 has a half-life of 5,730 years to determine the age of artifacts and carbon dating. Write the exponential decay function for a 24 milligram sample. So starting with 24 milligrams, and again, it is a half-life, so we have our 1/2 in there for that potency. But now, again, the life cycle of this is not the same as a life cycle that we would think of. I mean, it's 5,730 years, for goodness sake. So each year is 1/5,730th of its life. So that's what we would want to use as our decay function. And then it says, how much would be left after 30 millennium? Well, 30 millennium, each millennium is 1,000 years. So that's 30,000 years that we're talking about for X. So this time I'm going to talk through this and do this just following the order of operations. So I'm going to do parentheses here, 1 divided by 5,730. And then I'm going to take that times 30,000. And now I have that answer, so I'm going to punch in 0.5 to second negative button because that'll raise that 0.5 to the answer that I just had, and then take that times the 24. So just kind of following the order of operations as we go back through there so we can get what we need. 0.6369978,492, so approximately 0.64 milligrams. Both of those really good problems if you're going to get into physics at all. All right, number 42, physics formula. At a constant temperature, the atmospheric pressure P in pascals is given by that little formula we see there. and h is the altitude in meters. What is p at an altitude of 500 meters? So we need to put 500 in there. And I think I'd do this one just like the last one, where I'd say, okay, you know what, I'm going to take care of that power first. So I'm going to punch in negative 0.001 times 500, or you do that math in your head either way. You'll get the right answer when you go through that. So negative 0.5. And then I need second e to the, and then it'll be second negative for answer, raising that e to that power of negative 0.5, and then times 101.3. And 61.44155583. And did they say what they wanted this in? Well, then we'll go to tenths in pascals, so 61.4 pascals. And there it is. Then I had some review problems that I wanted to go over with you. You probably don't need these, but just in case. We can only add like radicals. So the first thing we have to do is simplify the square root of 75 and the square root of 125. And the square root of 75 will be the square root of 25 times the square root of 3. And then the square root of 125 will be the square root of 25 times the square root of 5. So this will be 5 square roots of 3 plus 5 square roots of 5. And we realize we can't go any farther with that one because you can only add like radicals. And those are not like radicals. So that answer is perfectly fine. Another thing you could do would be to factor out the 5. But either way, I mean, that's as far as we go. There's nothing else that we can do with that because those radicals are not like radicals. If they are like radicals, then we could go ahead and do the addition and the subtraction. Then number 63 says find the inverse and is the inverse a function. Again, make f of x y. Switch the x and the y, and then solve for y. So we'd subtract 1 from both sides. Then we would divide by 5. And probably clean that up a little bit. And what I mean by that is write it as 1/5 x minus 1/5. And then take the cubed root of both sides. And cube root does not require that plus or minus piece. We don't need that. So it asks, is the inverse a function? And that would be yes, because we don't see any plus or minus popping up that would have come from an original problem that had an even power in it. So the inverse will be a function. And that should do it.